right, hi there. So this is going to be a quick little video that's going to help with the activity that you missed in class. We're just going to run through number 1, and then we're going to go through number 3, and I'll help you out with what the idea of this is, and then you can go back and complete the remaining functions, okay? So what we're going to do is we're going to start with a quadratic function, which should be familiar, okay? And we could sketch this. The first thing we're going to do is we're going to sketch f of x equals 4 minus x squared. But I do want to encourage, you can utilize your calculator. Okay, so we're going to type these into our calculator and just kind of sketch the graph from there. So I just typed it in y1, and when I hit graph, I do in fact see a parabola that has been reflected downward, and it's shifted up 4. So let's just go ahead and draw this right here. When we do our drawings, we're not going to go in and graph all the exact points. We want our drawing to, accurately reflect the graph, but we don't but after all, it can just be a sketch, okay? So the next thing we're going to do is we're going to complete a table of values. Now we already have the equation into y equals, so I'm going to hit second graph, which is the table, and I can go in and I can then scroll around and I can see all these different values. So I'm going to go back to the other page here, but this is already typed in, like I said. So on paper, you can just look at the table and we're going to start filling in these values. So what I see is that -5 is going to be -21. Okay, -4 is -12, -5, when x is -2, the y is 0, 3, 4, 3, and again, you just continue filling this in using the table that's in your calculator. Now, one thing that I notice here is that every single x value has an output. Okay, in fact, if you were to go on from -infinity to infinity, you would always have an output right here. And because of that, what we're going to do is we're going to shade on the number line the domain. The domain is the set of x values that has an output. Now, parabolas, you can see here that parabolas go on forever to the left and they go on forever to the right. And because of that, we end up shading the entire number line -infinity to infinity, because all of these x values right here, they all have corresponding y values. Okay, so when we go to then put the domain in words, we can say all real numbers because every number is part of the domain. So in words, we would say all real numbers. But the domain in symbols, which is interval notation, we would write from -infinity to infinity. Okay, well, that seems really pretty familiar. So what we want to do is let's use that concept and let's now look at a different type of function, like a rational function. So rational function is what our unit is going to be over. Okay, we'll talk more in depth over what a rational function is, but for today, I just want you to go in, I want you to graph it, and I want you to look at it. So when we type this in, we need to make sure that we put that denominator in a parenthesis, because we're not just dividing by x, we need to divide by the quantity x plus 2. So let's take a look at the graph. And it's interesting that one thing I see is that there is a break in the graph. And that break in the graph looks to me like it's at -2. So how are we going to sketch this? Well, we're going to basically make a dotted line right here at -2. Okay, that line is going to end up having a name. We're going to call it a vertical asymptote, which we'll get into. But it's this dotted line, it's this space in the graph that nothing is crossing. So the graph seems to go like this. It's like it's almost in two different branches. Okay, so I want to explore a little bit in the table what's causing that break right there. So go back to your calculator and hit second graph, and let's start looking at the table of values. And what we see is right here there's an error at -2. And so let's fill out this table right here. At -5, the value is going to be -0.3. We can just round these, okay, if you see these decimals in your calculator. -0.5, -1. Now at -2, we get an error. I'm going to actually put this in red so it stands out a little bit. And that's what's causing this break, is there's no output at -2. And then after that, -1 is 1. I see this is 0.5, this is 0.3, this is 0.25, and so on. And we just start getting different decimals for this. Okay, this was 0.16 okay, and this is 0.143. So we're just approximating these. Now, what are we going to do on the number line is this value right here at -2 does not have an output, so we're going to put an open circle because there's nothing right here at -2. But all the other x values have an output. All the other x values can be shaded, and all the x values that are bigger than -2 all have outputs. So that's what we're doing on the number line is we're shading all the x values that produce output values, and they all do except for right here at -2. So in words, we would say the domain is all real numbers, okay, except x equals -2. All right. So in symbols, what we would say is we would write that as from -infinity to -2 with a parenthesis because it's excluded, and then on the other side of -2 to infinity. And so that's what you're going to explore a little bit in this activity are some different things that can happen with the graph and what causes those. Okay, we can see where these errors occur and continue that conversation over the next couple of days of what is causing this error. So first, we just need to see where these errors occur, and again, we'll continue to talk about why they occur. Okay, so that's the idea of the activity. I want you to continue the rest of the functions and then bring your assignment back into class. Okay, thanks for watching. Hope this helped. Bye.